Okay, we're going to write one of our first proofs now in this class. So a proof is going to be a logical argument where we are going to link our given to what we are trying to actually prove. But once we prove something, then it becomes a theorem. You may use that over and over again and not have to prove it again after this. We'll do this in form of a paragraph. So you will have to write a paragraph for me. I'm going to write most of my sentences or statements in if-then form. You can see this from this diagram here how this is going to work. We're going to start with our given, and then we're going to link that all the way to what we are actually trying to prove with different statements and reasons. Okay, so you're going to have to say stuff like in if-then form quite a bit, and give me a reason at the same time. So if I say something, there has to be a reason for it. Give me that reason why you're saying it. Okay, so we're going to try one here. Oops, go to the next slide. Given that M is the midpoint of XY, write a paragraph proof to show that XM is congruent to MY. So I'm going to write this out just a little different for us. My given is that M is the midpoint of XY. And I'm trying to prove then XM is going to be congruent to MY. And I would draw ourselves a picture on this as well. So here's going to be my picture, here's going to be M right in the middle, here's X, and here is Y. I'm trying to prove that XM is congruent to MY. So we're going to start with our given. And I'm going to say if M is the midpoint of XY, then we should know that XM is equal to MY. Okay, notice how I started my statement. I said if, using the given up here, I started with that, okay, and then I wrote something after that. So once I know that M is the midpoint of XY, then XM is equal to MY. That's my statement, but now I need to give a reason for that. Okay, my reason for that is because of the definition of a midpoint. So I'm going to say if M is the midpoint of XY, then XM is equal to MY because of the definition of a midpoint. So I gave my statement, and then I gave a reason. There's my first sentence. Okay, let's get another one. Now I want to link that statement to something else. So I'm going to really start trying to use the law of syllogism that we learned about in a couple sections before this. So I'm going to start with my conclusion from my first statement. So I'm going to say if XM equals MY, that's going to be my next statement. So if XM equals MY, then those segments have the same measure. Okay, there's my second sentence. Okay, and then if segments have the same measure, this is going to be my final statement, really, because I'm trying to link it together. If segments have the same measure, then my segment should be congruent. That is the definition of congruence in itself. So I'm going to state then if segments have the same measure, then they are congruent, which is the definition of congruence. So I'm going to state that by the definition of congruence. Okay, I got one last thing that I have to actually add in here. Okay, it's for my specific example that I was trying to prove. So now I just stated if they have the same measure, then they are congruent. Well, that's from up above. So since I had xm equal to my, then we know that they are actually congruent. So I'm just going to say therefore, very strong word in an argument. So therefore, xm is congruent to my. And notice how I link every statement with its previous one. Okay? That is how we develop and how we write a proof. You're going to continue to link your statements together until you reach what you are actually trying to prove. Once you do that, then you are done. Therefore, now that you have actually done this, you have created your first theorem. I gotta see if I can find it on here. Nope, that's not the right one. There it is, right down here at the bottom. You have actually proved this now. And saying, if M is the midpoint of AB, then AM is congruent to MB. You may use that theorem from now on. You don't ever have to prove it again. Okay?